So in the last video we left off talking about pentane and pentene, and something else that is mentioned in level 1 is whether it is a saturated hydrocarbon or unsaturated hydrocarbon. So this actually is similar to the idea of saturated and unsaturated fats. Basically, if you have a saturated hydrocarbon, that means it's full of hydrogens, as much as you possibly can have. So anything ending with ane has the most hydrocarbons possible. So this guy is, I know my screen is getting messy, but this guy is considered to be saturated because it's full of hydrogens. In the second example, pentene, it ends in ene because of the double bond. You could have more hydrogens. Like if this double bond wasn't here, then you would have another bond here and another bond here. And they would both be to hydrogens. So it's not saturated, it's not full of hydrogens. It's considered to be unsaturated. You know, just kind of like a sponge. Like if a sponge is saturated, it's like full of water, and if it's unsaturated, you can have more water in your sponge. So the double bond and triple bond hydrocarbons are considered to be unsaturated. Sorry, my screen is cutting off there. Unsaturated because it's not full of hydrogen. Alright, in this video, we're just going to do a whole bunch more practice problems of me making random compounds, going through and writing the general formula, naming it, and figuring out whether it's saturated and unsaturated. So for number 3, I didn't finish putting the lines on all of my carbons. How many lines do you think, how many more bonds does this carbon need? The one that's on the end right here. Yep, so it needs 3 more bonds so that it has a total of 4. How many more bonds do you think this carbon needs? So this middle guy needs 2 more bonds so that it can also have 4. So all of the middle guys that already have 2 bonds are going to get 2 more to make 4. And the end guys, because this guy only has, this one only has 1, it needs 3 more. What about this carbon? This carbon has a triple bond. So how many more bonds does it need? It only needs 1 more bond. And if you're not sure like where to draw the line, that's not a big deal if you drew the line like up here. It is most accurate to draw it this way. The reasoning for that we are not going to go into because this is just like a brief introduction to organic chemistry. But it has to do with the orbitals and how they're positioned. What about this carbon? How many more bonds does it need? So it doesn't need any more bonds because it already has 4. 1, 2, 3, 4. What about this guy? This one needs 2 more. This one also needs 2 more, 2 more, and then the last one needs 3. So again, all these lines are going to hydrogens, but I'm not going to write them in, so it looks kind of neater, if you will. Alright, let's work on naming this first number 3, this compound. So again, we want to figure out which prefix to use first. I have 1, 2, 3, 4, 5, 6 carbons, so its prefix is hex. So we're going to just write hex. And if we look at the second one, 1, 2, 3, 4, 5, 6, the number 4 also has 6 carbons, so this guy also is going to start with hex. Okay. So now we have to figure out what the end of the name is, and again, if you are single bonds, you're going to end in "-ane". If you're double bonds, you're going to end in "-ene", and triple bonds will end in "-ine". So, for number 3, they're all single bonds here, so it's going to end in "-ane". Notice how, again, this little picture on the side, there's only single bonds between the carbons. So, number 3's name is hexane. For number 4, there is a triple bond right here, so we are going to end that name in "-ine", Y-N-E. So this is hexine. Okay, so now that we have the name of the compound, I want to figure out what the general formula is. But I don't want to go through and count all the hydrogens because that's just annoying. It's too much work. So, I'm going to start with number 3. Again, I know this has 6 carbons, and it's in the category of alkanes because it has all single bonds. So I'm going to use this formula. So we have C6 is where we start off with. So our N is 6 because there are 6 carbons. So to figure out the hydrogen side, that's always where you have to do the math. So it's going to be, you're just plugging in 6 for N. So 2 times 6 plus 2 is 14, because 2 times 6 is 12, plus 2 gets you 14. So that is our general formula for this guy, C6H14. And if you want to check me, you could pause the video and go through and count how many hydrogens would be surrounding these carbons, and you should get 14. If you don't, let me know. Alright, let's figure out the general formula for hexine. So again, we have 6 carbons, but we're going to now use this formula because it is an alkyne. So I'm just going to write right here. It looks like I'm writing it as if it's an alkene. I'm writing it, there's just not space below it, but I'm writing it as if it's an alkyne. So C6, we have to figure out how many hydrogens there are. So again, we're going to just use the little formula right here. 2 times N, again, N is 6. We figure that out because it's just how many carbons there are. That will always be your N, just how many carbons there are. So 2 times 6 is 12, except now it's minus 2. So it leaves us with 10. So C6H10 is the formula for this guy. And you can check by counting how many lines are going around it. There should be 10. Let's just do that really quick. So here we have 4, 5, 6, 7, 8, 9, 10. So this is correct. Okay, the last thing I want to do is I want to label whether it is a saturated or an unsaturated hydrocarbon. So this guy, hexane, is it full of hydrogens? Does it have as many hydrogens as it possibly can? Yes. All of the bonds are single bonds. As long as you have any alkane, alkanes will always be saturated. They'll always be full of hydrogens. And these two guys will always be unsaturated because the double bond or triple bond is hindering you from having more hydrogens. You could have more hydrogens here, but you don't. So this guy is considered to be saturated. and this guy is considered to be unsaturated. Actually, the very last thing I want to do is figure out what the empirical formula is for these compounds. So we wrote the general formula, which is the same thing as the molecular formula. Again, the empirical formula is simplified. So C6H14, that could be simplified to, let's see, C3H7. I think that's the simplest. Yeah, so this could each be divided by 2. So the empirical formula is C3H7. That's like the simplest repeating unit. And this is the general formula, otherwise known as molecular formula. And for this guy, again, this is also the general formula, otherwise known as molecular formula. And you can simplify this one also, because 6 and 10 are divisible by 2 as well. So it simplifies to C3H5. This is your empirical formula. Okay. I am now going to give you a problem where I give you the general formula. I'm going to give you one of these guys, and you have to figure out whether it is an alkane, an alkene, or alkyne, and you're going to name it. Okay, so for number 5, I have the formula, the general formula, C2H4. So which compound is it? Is it in the category of alkynes with triple bonds, alkenes double bonds, or alkanes single bond? So you first have to, you could start by just drawing it to figure it out, or you could try to like reverse mathematically figure it out. I'm gonna go with the reverse mathematical way first. So we have C2H4. So again, this is your N number. So your N here for number 5, N is equal to 2. So if you go down and see which formula best fits. So if your N is 2, let's try and see what we would get if it's an alkane. So if our N is 2, it would be C2H, let's see, 2 times 2 is 4, plus 2 is 6. So if it was an alkane, it would be formula C2H6. It is not C2H6. So let's try it for the alkene. So here we have our C2, and then H is just 2 times, again, your N is 2 here. So it's 2 times 2 is 4. So our alkene is C2H4. So that is actually the same thing, C2H4. So we know it's an alkene, which means that it's going to have a double bond. So let's draw it. Even if you didn't know it was going to be an alkene and you just decided to try to draw it, you could have also figured it out that way, because if you do 2 carbons and you know that you're going to have 4 hydrogens around it, so these guys need to be bonded. And then you have to have 4 bonds around the carbons. Right now they each only have 2 bonds. You have 1 bond here and 1 bond here. So they're going to need to form at least 2 bonds to each other, which is what we expected because, again, we already said that it would be an alkene. Okay. So I am running out of time, and we'll do number 6 in the next video.